Okay, here we go with the start of chapter 18. We're going to cover 18-1 and 18-2 today, but all of chapter 18 we call transformation. So all of these fall under that kind of general heading. Um, I actually don't care if you actually write all this out yourself. If you want to print this out, I'm totally fine with that, but obviously follow along as best you can. So the first topic is reflection, what a reflection is, in particular of a point across a line. Now, I know what you think of in terms of a reflection, if you're looking in a lake or a mirror or something like that. And basically this is the same concept, but here we're talking of a point across a line. So we're reflecting a point across a line. So if we started with P1 here, point 1, and this is our line that we're reflecting across, the reflection point, P2, is the same distance away, and this segment that connects P1 and P2 is the perpendicular bisector. It is perpendicular. It's bisected by that line that we're reflecting across of. So notice how we have a right angle there. We have this is congruent to this distance here. So how would this help you in terms of having to reflect P1 across this line? You would basically figure out, okay, I'm going to find the perpendicular, this distance, and I'm going to basically count over or find the same distance, measure over the same distance this way, using a ruler. And a clear ruler is really helpful for this stuff because you can really kind of set it up to be perpendicular pretty easily. Okay, line symmetry. What is line symmetry? Line symmetry is a set of points has line symmetry if there is a line that reflects the set onto itself. So basically think of last year when you guys did parabolas, right? Remember how we always had that axis of symmetry? Well, that's exactly one of the ways that we can call this particular line that we're reflecting a set onto. So remember, like if you had a parabola, right, you could fold half the parabola over onto the other half. And we called it, on the axis of symmetry. That's what line symmetry is. So it's just, yeah. So basically that works for all different types of shapes, not just parabolas. Okay. We then have something called point symmetry, and that's reflecting a point across another point. Okay. So the point of symmetry is the midpoint of P prime, right? So the midpoint is between them, right? It's right halfway in between them, okay? So those are the different types. So line symmetry, point symmetry, and we've talked about kind of what a reflection is. Okay, so the theorem basically says if a figure is symmetric about each of two perpendicular lines, then it is point symmetric where the lines intersect. So that point would be where there's point symmetry for the entire figure, okay? So we're going to look at some examples of that in a moment. So here, I don't wonder if you know who this is. It's actually, I believe, Edgar Allan Poe. And the question is there symmetry here? And in other words, is there line symmetry? It wouldn't be point symmetry, that wouldn't make sense, but is there line symmetry? In other words, if you drew a line kind of up through the middle of him, would the two sides fold onto each other? And what do you think with this one? Hopefully you said no. You can see that his hair would certainly affect that. Is there other things that would affect it? Looks like maybe his mustache is off by a little bit. Here he's got kind of a darker crease shadow. This side he doesn't, so forth. Here you can see a little bit of his ear. Here you can't. Okay, let's look at these ones though down here. What do you think about these? These look like they do to me. And here's kind of one with some markings on it, so you can see like an axis of symmetry. They've picked out a few different points that would definitely fold over onto each other. So I think those would. Okay, so let's take a look at symmetry and reflections and go through this worksheet. So again, one point is the reflection of another across a line if the line is the perpendicular bisector of the segment joining the 2 points. Okay. So we want this line, or this line, whatever we're talking about, has to be the perpendicular bisector from the original point and the point we're reflecting across. Okay? All right. The reflection of a point P across a point Q is the point P prime such that Q is the midpoint of P prime. Okay? So basically what we do is we look here and we say, okay, here's P. It's obviously, if I'm going to reflect it across this line, it's going to be on the other side here, right? So we want to basically set it up so that we have P be the endpoint of a segment that is bisected and is perpendicular to this line. So you literally can take a ruler, and let's see how well this works, but these are hard to manipulate. But you basically can take your ruler and let's see if I can get this to, you want to kind of lay it down on point P, and you could use the end of the ruler or whatever. You could go like this, although usually it's better if you set up. So that's not quite, that looks better. Okay, so now that looks like it's pretty much perpendicular to this line, right? So you can use kind of the hash marks here. So I'm going to put 4 centimeter 4 right on that line, right, and going through P here. So then you could literally measure how far it is here. Or what else could you do? Yeah, you actually could use a compass, couldn't you, and just kind of measure that there and then go out this way after you've kind of drawn this line. But as far as I'm concerned, it's fine if you just want to use a ruler and see, okay, this looks like it is, what, 2.3 centimeters to the right. So you could go and plot this point there. Okay. All right. With this figure, how many points do you think we would need to plot in order to then be able to connect the dots? Well, it's a triangle, so hopefully you said 3, right? So again, notice what I'm doing. I would basically was using a ruler to figure out, setting it up so that it looked like it was perpendicular to the line, going through this point up here. And then I would basically say measure. So I'm at 3, and it looks like it's going a little past 6. So, 3.3 centimeters one way. So I'd want to count 3.3 centimeters the other way. Or again, I could make a little arc, put a little mark there. And then I would do the same thing for this point and the same thing for that point. What am I going to end up with? I'm then going to have a point right here, and right here. And then I can connect the dots. So try that. Okay. All right. And then go ahead and give number 3 a shot. So you want to pause the video and go ahead and do that. All right, so I'm back. So this one was interesting, right? Because we had 1 point, 2 points, 3 points. And so you had to reflect this point, again, across this line. So it would be over here. This one would be over here. And this one would be over here. Again, notice how, if I bring my ruler down here, I'm basically trying to set something up that's perpendicular. It's not quite, but that looks a little better. So you can see how I did that. So like, I could put my compass at 4, or my ruler at 4, and see that this is about a distance of what, 1.5 centimeters, I guess, 1.4 centimeters. And then I could plot that point right there. Okay. And then obviously using a straight edge to connect my 3 points that I drew. All right, try number 4. Get this out of the way. Okay, so here we had a flag, right? And this was our original on this side. So how many points did you reflect across in order to be able to draw the flag over here? Probably 1 there, 1 there, 1 there, and 1 there, right? So I should see 4 of these types of lines across here. And then once you did that, you can connect the dots. Okay. All right, now I want you to draw each line of symmetry in for these figures, okay? So remember, line of symmetry means where we'd be able to fold over, right? So for this rectangle, I initially had 4 of them, but you can see it's actually just 2. It's just the horizontal and the vertical. So if you fold it along this vertical, the figure would fold upon itself. Initially, I had the diagonals in, but if you think about it, they actually don't fold onto each other. Okay, so would there be point symmetry? Remember what point symmetry means. Point symmetry occurs when you have what? When a figure is symmetric about each of 2 perpendicular lines. Well, in this case, didn't want to do that. And in this case, do we have two perpendicular lines? We sure do, horizontal, vertical, right? So the answer is yes. In other words, if you think about it, from this center point right here where these 2 lines of symmetry meet, if I pick a point like anywhere on the figure and I draw that segment to that center point and then just keep going till I hit the figure on the other side, we're going to have symmetry. It's going to end up being on the figure. So like if I pick this point here, it's going to be over here. Okay, try the next one. All right, I'm back. So here, hopefully you just had that 1. And so would there be point symmetry here? Answer would be nope, it wouldn't be. Okay. Think about it. Like if you did think there was point symmetry, where would it be? Where every single point could be reflected through that. It's not going to happen. Okay, try the next one. So here with the square, hopefully you got all 4 of the lines of symmetry. Is there point symmetry? Yep, sure is. Okay, so notice if I pick a point right here, it's going to end up over there. If I pick a point here, it's going to end up over there. Okay, staying on the figure. Okay, try the last one. So with the oval, there definitely is 2 lines of symmetry here. You can see that if you folded it across the horizontal line of symmetry, it would fall onto itself. Same thing with the vertical, it would flip over. And all right, thanks. Just got my coffee. So is there point symmetry? You betcha. All right, awesome. Okay, so I want you to write a few capital letters of the alphabet that have line or point symmetry. And then which ones have point symmetry. So start thinking about it. And I know it may depend on how you draw your letters. But go ahead and kind of go through the alphabet. And I'll go ahead and give you a little head start. So does A have line symmetry? Yeah, it sure does, right? It would be right here cutting down this way. All right. And then what about B? Yeah, B would. Where would it be? Where would the line of symmetry be? Hopefully you said right across here like that. All right, so go ahead and go through the alphabet, see what you come up with. I think I might have gotten them all. Let's see. But go ahead and try it. See what you come up with. Okay, so there you have it. If you have questions on any of these, let me know. Some of them are pretty easy to see. Others, maybe not so much. Where is it for T? Yeah, it's actually vertical here like this, right? It's just that the vertical part of the T just folds right on itself. I mean, you don't have to fold it. It's like right on the line of symmetry. Okay. And if you have questions to these, obviously you're doing this while we're in class, so I'd be happy to help you. So which ones have point symmetry? I came up with I, N, Z, H, S, O, and X. Okay, now I want you to come up with some words that have line symmetry. And there's all kinds of words. These are just some examples, but here's one. just to get you started. Hic, can you see where the line symmetry would be? It would be right across there, right? Fold upon itself. So see what else you can come up with. And here's some of the ones that I got. He, bed, high, deck, code, hex, dick. And what did I have over here? Oh, and this is one, I think, this is what am I doing here? Let's see. Oh, Otto. Look at that. Nice. Bob. Okay. All right, and then I'd like you to finish off by drawing a line, a design that has line symmetry. So here's an example of one. Kind of looks like a pine tree or Christmas tree of sorts. Okay, and you can have it so that it has more than one line of symmetry if you like. All right, so that's an introduction there to kind of reflections and symmetries. Kind of fun stuff to do, and we'll continue on transformations in the next lesson on 18.3 and 18.4.